Math 1314, Tyler Junior College, Section 4.1, Exponential Functions. Graphing exponential functions, Part 4. Write this a little more clearly. As I mentioned at the end of the previous video, I wanted to do 2 examples, but doing them both in one video would have made a third long video in a row, and I didn't want to do that. So we'll just do it in its own video. We're going to graph f of x equals 1/2 to the 3x power minus 1. Let's start by analyzing what the function would look like without any of its transformations, namely without the 3 and without the minus 1, and just look at y equals 1/2 to the x power. Since its base is less than 1, but still positive, we would get exponential decay. The reciprocal base point would be -2, the reciprocal of 1/2, which is 2. So we'd have a point at -1, 2, right there. The y-intercept is still 0, 1, and it will always be that without transformations done to the function. And then the base point is 1, the base, so over 1 up 1/2. The horizontal asymptote will be at y equals 0, and we have our exponential decay, which we'll go ahead and sketch this. And remember, this is the function without any additional transformations. So just the 1/2 to the x power. But let's see if we can remember what these different transformations to the function will do to the graph. Starting with the shape of the graph. Remember, the movement is what you want to do last. You always want to determine the shape of the graph in addition to any reflections before you move it around. The shapes are changed by multiplications and negatives, and we have a multiplication in front of the 3. When you multiply the x, it invokes a horizontal, a horizontal, I want to say compression. It's a stretch, but it's the opposite direction. This is where filming this video so long after the videos that I filmed for 2.5 is coming back to haunt me. Recall that I filmed those videos back this summer, and for those watching this now, it's December 19th, December 18th, one of those days. But anyway, it's a horizontal, we'll say a horizontal compression by 1/3. So it does stretch it in the x direction, but the opposite of what you expect. You expect times 3 to stretch it out by a factor of 3, but it compresses it by a factor of 1/3. This minus 1, that's pretty predictable. That's just going to cause it to move down 1. So we're going to do the same thing we did in the previous video. We're going to keep track of all the points and the horizontal asymptote, which is at y equals 0, and see where they wind up under these transformations. Our base point was 1, 1/2. Our y-intercept was 0, 1. Our reciprocal base point was -1, 2. And our horizontal asymptote is still y equals 0. Let's start by the compression by 1/3. So horizontal compression by 1/3. What that means is that each of the x coordinates will get multiplied by 1/3. So we go to each x and multiply it by 1/3. 1 times 1/3 is 1/3, and then the y stays the same. 0 times 1/3 is 0, and the y stays the same. -1 times 1/3 is -1/3, and then the y stays the same. And here, there is no x to multiply by 1/3, and so it stays y equals 0. Our last move is easy. We move down 1. Down 1. And when you move something down 1, you subtract 1 from its y coordinate. And so we just go subtract 1 from each of these y's. That gives us 1/3, 1/2 minus 1 is -1/2. 0, remember we're subtracting 1 from the y's. 1 minus 1 is 0, so that puts us at the origin. And then -1/3, subtract 1 from this y. 2 minus 1 is 1. And since this says y equals, we subtract 1 from it and get y equals -1. Now we just have to replot and graph. All right, So y equals -1 will be down here. Our base point is now at 1/3 common -1/2. So we have to kind of imagine cutting this into thirds, since we're referring to them. 1/3 common, and we might as well cut this in half. 1/3 common -1/2 is about here. 0, 0, that's easy. And -1/3 comma 1 is right here. And so by compressing these points get a lot closer to each other, so we get a really fast drop from here, and then we start hitting the x-axis, the horizontal asymptote. All right, so it did get squished and shoved down one, which is exactly what we expected. Now, if this were a multiple choice question on a homework platform, then you could actually just look at the answer choices and probably pick the correct one. But as a graph done manually, it's a good idea to keep up with as much evidence as you can, which in this case were the base point, the y-intercept, and the reciprocal base point, and we followed their journey through the compressions and the shift downward.